all your scales team up together. It's Emily and good to see you again. Hope you all are doing well. So for who can attend our class on Tuesday, Ben, could you please introduce yourself to our audience again?
This is Ben. I'm CEO of WellSpot International. I'm glad to be here again.
Thank you so much. So let's make a quick review of what we learned on Tuesday.
Well, from last session, we learned a lot about a robot. And there are three main parts of a robot. Can you remember what they are?
The three main parts of the robot. So the first one is the controller, and the second is the actuators and the sensors. Is this correct?
Very good. And we also talked a great deal about structural part. You were referring to as
muscles.
Yeah, muscle and skeleton. Very good analogy. And actually, we also talk about how important that is to start the STEAM education from something simple. And Dr. Ye start from hand rolling fan and add motor and add a sensor switch and to make
the fan to drive, to control the fan.
Yes, exactly. And I think also the key knowledge he passed on is about the gear, especially gear ratio, and we talk a lot about
how to calculate the gear ratio.
Yeah, gear ratio, and the big gear drive the small gear. Actually, turn this way, we can see better. Yeah. And the key subject is kind of a sustainable energy, right?
Right.
So for electrical fan, that's the wing actually blowing out this way. So if the wing blowing this direction, actually...
It's a windmill.
Yes, exactly. We can make a windmill out of that. And also the gear, if we put the gear another way around, and the wing, it can generate to get this wheel to move and to generate electricity.
The wind power. That is exactly the wind power.
Yeah.
So what will we learn today?
Today we're going to extend more on gear. If there are two gears, from last session we talked about the two gear that really touches each other. The two gear kind of meshes together, and today we're going to talk about if the two gear
two gears cannot match together.
Yeah, cannot match together. They are distance apart.
How can we do?
Yeah, how can we transfer the energy?
Yes.
Yeah.
So
what do you think? And tell us what you think of. What can we do?
So, like we can use the Tseng.
Yeah, that's a very good example.
So that is the
to use chain drive.
You can see the two gears over here, and we can use the chain to let it to drive together. Right?
Exactly. Very good.
So before we start our class, the audience can think about what is the Tseng application of our daily life.
And if we have the two gear that is connected by a chain or connected by a belt, we call it a different name. We call it a sprocket.
Sprocket.
Okay. That's another fancy word for gear.
So if you have any answer about the Tseng application, just leave your comment below and we will see your answer. So let's move on to Dr. Ye and start our class.
In today's lesson, we will continue to talk about robotics coding with WellSpot AI Module 1. But today we want to focus specifically on Sprocket concepts, build a project called Moving Walkway, we will do the coding for the moving walkway. So let's look what we're going to talk about today. The first part, we will talk about the concept of sprockets, also called train wheel. In the second part, we will build a moving walkway. In the third part, we will do graphical coding so that our project, the moving walkway, will start to work. And in the fourth part, we will use scratch coding for moving walkway. Now let's go to the first part, the concept of sprockets. This is the gear drive that we have covered last time. In this case, there are two gears interlocking with each other. If the left gear is the drive gear, then the right gear will be the driven gear. As we all know, if the drive gear has less teeth compared to the driven gear, which means the large gear will drive slower compared to the small gear. In this case, as we can see, these two gears, their rotation directions are actually opposite to each other. For instance, the left gear rotates clockwise, and the right gear rotates counterclockwise. This is very different compared to train wheel or the sprockets. As you can see from this image, these two sprockets are driven by the train, and if you look at them carefully, both of them are rotating clockwise. Sprocket is also known as train wheels, and they are mainly used in bicycles, motorcycles, cars, and other machinery, either to transmit rotational motion between two shafts where gears are unsuited, or to impart linear motion to a track. In this case, gear drive are not suited because if we use gear drive, these two gears will rotate at opposite direction. That's what we don't want. So let's look at the comparison again. The left side is the train wheel and the right side is the traditional gear drive. Another important point is that when we use train wheels, the distance between these two sprockets can be changed. It doesn't matter, as long as the train is long enough. But for the case of gear drive, they have to interlocking with each other, which means that they will always touch each other. So the distance between these two gears is fixed. And as we mentioned before, for the train wheel case, drive gear and the driven gear rotate at the same direction. And for the gear drive case, drive gear and the driven gear rotate at opposite directions. Train wheels are also used in bike. For instance, this is the bicycle. There are two sprockets in a bicycle, a larger one and a small one. The large sprocket is connected with the pedal. So when we ride the bike, the pedal will be rotated, which will in turn rotate the big sprockets, and then by using the train, the small sprockets will also be rotated. Let's take a close look at the sprockets on the bike. So the two sprockets are connected by the metal train as shown in the picture. We can also find train wheels in auto walk, also known as a moving walkway. Is a slow-moving curvy mechanism that transports people. You can easily find them in airports because airport is very large. If you want to go to different terminals, you have to walk for long distance. That's why they use auto walk so much in airports. It can save people's time. You can also find train wheels in escalator, in shopping mall, in buildings. Train wheel can also be found in weapon. A very famous weapon is the tank. The purpose of using train wheels in tank is to increase the touching area of the tank to the surface of the ground, so that the tank can move easily on the ground. Next, we will do a live demo to build a real train wheel using the structural parts that is included in AI Module 1. So now we are going to build a train wheel. Here we have two sprockets, and we can take a close look at them. And then we also need caterpillar wheels, which is this component. And we need a lot of them, so I can have another one, and they can be interlocked just by press. Now they are locked together. It will not move out now. Of course, we can take it out just by doing that. Okay, so we need more of that. Now we have 3, 4, and of course you cannot do like this. 5, 6, 7, 8, 9, 10. Let's see how long it is now. This is 10, and we can do like that, right? But it cannot be put inside now, so how can we do that? Oh, let's take it out and do like this and try to see. Now this is fixed, but actually this is not what we want. We want the train to lock both sprockets. So let's take it apart again, and then we should continue to extend the wheel. So let's make another part. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And of course we can have more. 11, 12, 13, and 14. Finally, we can connect them together. So the length is 24, and eventually we will combine them with the sprockets. So for instance, we can do like this, and then this one will be here, and then we can fix it like this. Let's see. But if we put them on the table, or if we put it on the side, this is not fixed, as you can see. So how can we do that? Well, we need a beam to fix them. So just take out a beam, and let's try to see if they can just match. Yeah, they can match like this. So it's also important to note that the beam has round hole and cross hole. So if we put like this, what do you think? Is a good idea or not? Well, we can try it out. So we can use the bolts to connect them, and then put them into the sprockets. Okay. Okay, now it's fixed. But let's try if it can rotate. Oh, it cannot rotate. Why is that? Well, because this is the cross hole, so the bolt inside cannot rotate. It's fixed. Which means this is not a successful design. So we need to change it. Let's take this part out. And we need to change to a round hole like this. And now let's see if they can move. Yeah, it's working, right? Very cool. So now this is like a one part of the tank, and we can build another one if we want to build a tank project. But in this project, we just want to make a train wheel to demonstrate how it works. So that's it. Now let's turn back to Ben and Emily to summarize what we have covered in part 1, and then do the pop quiz.
Thank you, Dr. Ye. And from the chain drive system Dr. Ye just built, we can learn. Actually, we use a chain to transfer energy And also the sprocket direction-wise, if we have a sprocket, two sprocket move inside of the chain loop,
Yes.
it's going on the same direction.
Yes, as we can see, the direction is moving the same.
Yeah. And for last lesson, if we have the gear that touch each other, the gear that meshes together, and if we turn the gear, actually the two gears going on the opposite direction.
Right.
So that's the difference. And I have a question for you. If we have the wheel that goes outside of the chain loop,
yes.
which direction you think the wheel will go?
So if the chain loop go this direction,
Yes.
and how well this go do? I guess that this will go to that direction. If the loop is going this side and this
Yeah,
is
if
going
outside
outside.
if outside the loop, that wheel goes opposite direction.
Oh, so
That's
I got
correct.
it correct.
Yeah. And also we can think of the large whale and a small whale. I have put together this little gadget here. As you can see, I linked the two whale with the belt. Actually, it's a rubber band. Yeah, I linked together with the rubber band.
Yes.
And I also suggest that the teacher, if you want to make STEAM lesson, you can
This
make
is
something
easy
simple.
tool.
Yeah.
Yes.
And so if we turn this, it's not obvious to see the wheel turning, so I make this indicator. So you can see if that I turn this, they look the same, but actually I have this side rounded on the smaller wheel, and this side on the bigger wheel.
So the two
Right.
horse is not on the same loop.
And if I turn this, probably like this. If I turn this, I make one turn, and the bigger wheel just turn halfway.
Yes.
Yeah, so in this case, the principle is pretty much the same like the gear that touches each other, right? If you have a smaller gear that drives a large gear, so the large gear will turn slower. And also, this is a way we save energy,
Oh, right.
right? And the output torque will be larger. Will amplify the output torque, right? So if we ride a bike on the upper hill, so we want to ride on the smaller wheel, right?
Yes. The bicycle
And
is
if we want to ride quicker, we'll probably ride this way.
yes. So
Right.
the bicycle is also
Okay.
a effort-saving structure.
Yes.
So is anyone come up with the application of the chain wheel?
And I also noticed that it's very interesting that Dr. Ye show this.
Show us.
Yeah, show this, and actually, I have a question for you.
For me, okay.
Yes, and knowing that each piece of a caterpillar is 1.5 centimeter.
1.5.
Yeah, and do we know? Can we calculate the diameter of this sprocket?
The diameter? Okay, so we have to count 1.5, and there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 caterpillar here.
Yes.
So the length is 15.
It's 15.
Yes.
15 centimeter length.
And we have to.
So the circumference of the whale is 15 centimeter. So the relationship between circumference and the diameter is a ratio of pi, right?
Yes.
So what is the diameter? For those of you is watching this, you can also
Calculate.
give us the answer. If you have a calculator, you can give us the answer. The pi is 3.14. Yeah. So you divided 15 by 3.14. It's roughly about 4.7. Okay.
So just like we take the MRT, and the Tseng whale is a kind of the escalator. If everyone noticed that if we take the MRT, there is a sensor at the front of the escalator. If it detects that someone approaching, and the escalator will start moving, and otherwise it will stop. So it's kind of energy saving.
Yes. We can ask Dr. Ye to make us an escalator later on in his class.
Oh yes, the moving way. So let's move on to pop quiz first. The first question, which of the following doesn't use a sprocket? That is an easy question. So.
Well, the answer is quite obvious. I don't think anyone will answer it wrong. It's a C, computer. Dr. Ye made this question very easy for you, I think, today. And,
for the class begin.
Yeah. Perhaps later on in the future we can use Sprocket on the computer and make the computer following us, coming with us. Yeah.
So now it's the break time. Later on, the Dr. Ye will show us how to build a moving way.